Okay guys, so let's consider this case. Let's say we are given a spherical structure, a sphere, which contains three different types of charges as shown here. We have a negative volume charge in the middle, and we also have a positive surface charge at R equal to B, and we have a positive volume charge between C and D. So now we are going to find the expressions of E field using a Gauss law, because this is symmetrical structure, so Gauss law is the best law to be used. Okay, so let's consider the first part. I want to find the E for the first region less than E. So again, we have to choose any point within this region. Let's say this is my point of interest. I choose myself. So now to apply Gauss law, we need to draw our Gaussian surface. So let's draw together. So that's our Gaussian surface. And guys, this surface must also in spherical structure. Okay, must follow the original structure that we are given here. So now applying Gauss law, close integrations d dot ds is equal to the charge enclosed. Okay guys, if you can see closely to this diagram, we have charge enclosed but not all, right? Only a portion of the negative volume charge which appear between 0 and R, right? Because that's our radius of Gaussian surface. So but the charge only exists between 0 and R, so that is our charge enclosed, just a portion of the volume charge. So now, since in case of spherical, so the SKEE guys, we can absolutely have the value of 4 pi r squared, which comes from the r squared sine theta d theta d phi. You can do yourself. So now we can have the conversion of ds 4 pi r squared. Now finding the charge enclosed for these portions. So integrations and negative rho v dv. Okay guys, the same method, dv has to translate it to the r squared sine theta dr d theta d phi, and you can find the expression become 4 pi r squared. Now we have negative rho v 4 pi r cube over 3. Okay, that's a conversion of this dv, okay, whereby the charge exists between 0 and r. Okay, so now we can simplify the equations. So 4 pi and 4 pi r squared left 1 r. So now we have the first E for the first region given as negative rho v r over 3 epsilon naught r directions volt per meter. Okay guys, that's the E that exists in first regions. So now let's proceed to the next part of it. So I'm going to find the E field in the second region, which from A to B. So that is our region of interest. So again, to apply Gauss law, we need to choose any point within this region, and we need to draw our GS, your Gaussian surface. So let's say this is my point of interest. It has R radius. So we need to draw our GS that completely close and pass through the point. Alright, so guys, for this case, we can see that the charge that enclosed not only between 0 to R, but now it covers the whole negative volume charge. So for this case, we cover the whole charge here. So we can simply use the same result here, but change the R become A. Okay, so the second region, which is more than A and less than B, guys. So this case gonna have same Gaussian surface, which is 4 pi r squared. And now we have to consider the whole structure of negative volume charge, whereby we can find this value negative rho v 4 pi a cube over 3. So you can simplify the equation now, 4 pi and 4 pi there. So you can have the final equation of E obtained as negative rho v a cube over 3 epsilon naught r squared, r component volt per meter. Okay guys, this is your E field in second region. Okay, so now let's proceed to the next part. I'm going to find the E field in our third region, which from B to C. So again, we need to choose any point and we have to draw our GS. So let's say this is my point of interest, which has again a radius of R. Okay, and now we need to draw our GS that pass through the point of interest and also must completely close. And this is your GS in terms of spherical. Okay guys, so now if you look at carefully guys, for this case, now this third GS actually cover two different types of charges, which the first one is our negative volume charge, the whole area it covers, and also plus with a positive surface charge which appear at R equal to B. So these two charges actually enclosed within this third Gaussian surface, so we have to add up them. So in the case of more than B and less than C, so it's the same expression 4 pi, because this is your same GS, so must be have same expressions. Now we have to add two types of charges for the volume and also for the surface charge. I'm going to have here negative rho v 4 pi a cube over 3 for the volume charge in the middle, and plus the positive surface charge that actually exists at R equal to B. So now we can simply find the charge by multiplying the rho s and also the ds. Now we have the rho s given as rho s, and the ds actually is equal to the 4 pi b squared, right? That's the area of the sphere at R equal to B. So we're going to have here 4 pi b squared. Okay guys, so that's the conversion of ds. Now let's simplify the equation, 4 pi, 4 pi and 4 pi. Now let's finding the E. Can have here rho s b squared from here, and then minus rho v a cube over 3 over the whole term epsilon naught r squared. So let's simplify a bit. Now we have 3 b squared rho s minus rho v a cube over 3 epsilon naught r squared. Okay guys, that's our E expressions in third region. Okay, so now let's proceed finding the E field in our fourth region, actually in this region, right, between C and D. So again, applying the same method or procedure, we just choose any point and then we have to draw our complete Gaussian surface. This I just draw a bit to show you. You have to draw everything, the whole. So now applying the same concept, so the R which is less than C, less than D and more than C. So now guys, if you can see closely guys to this structure, the Gaussian surface here, let me draw for you the whole structure, because that's my whole Gaussian surface. in between C and D. Okay, that's our GS. Okay guys, so you can see guys, from here our GS, our fourth GS actually cover now 3 types of charges. The first one is the whole negative volume charge, and then plus the second here positive surface charge at R equal to B, and then the lastly a portions of the third volume charge as shown here. So that is our additional charge, okay, for the fourth Gaussian surface. So we have to add up all of them. So using the same expression here, d 4 pi r cube is your Gaussian surface. Now we have to add up everything, which negative rho v dv plus rho s ds plus guys now have positive rho v dv. Okay guys, so make sure guys for this dr you have to put the limit between c until r, right? Because our gs here has a radius of r, so that should be our limit of the charge enclosed. So for this integration you have to replace the limit between c until r. Okay, so now you can simply find the value of 4 pi r squared, again using the same value as obtained earlier up here. So just reuse in negative rho v 4 pi a cube over 3, and again the same value obtained earlier is shown up here, so just use again. Now we have rho s 4 pi b squared, and now again we have to integrate this volume integration, which has a limit of r between c until r. So now we have to exclude a bit, so you can proceed as so you can have these equations. Rho v 4 pi r cube minus c cube over 3. So that is our conversions after we integrate this part. Okay guys, let's simplify the equation. So again 4 pi, just did L. So now you can find this E, which appear in fourth regions. You can have here 3 b squared rho s minus rho v a cube plus rho v now r cube minus c cube over the whole term 3 epsilon naught r squared. Okay guys, so that is our E expressions which exists in our fourth region from C to D. So you can simply change this R any value between C and D. Okay guys, so you can simply proceed the step in finding the fifth E, which exists in fifth region, by changing this R equal to D, right? Because our fifth Gaussian surface covers the whole charges, which is full of negative volume charge, full of rho s, and also full of positive volume charge at the outer part here. So just change this Q enclosed equal to D, right? So we have D cubed in the end. So you can simply jot down here the E number 5. Just repeat the same expression, D b squared rho s minus rho v a cube plus rho v now d cube minus c cube over the t 3 epsilon naught r squared. Okay guys, so this is our final expressions for the E field that actually exists in the outer regions of this spherical structure for the case of R more than D. Right guys, so I hope you can try yourself and make sure you really understand the flow, the concept. So make sure you use the correct conversions for every ds and dv for the case of spherical as well as case of cylindrical structure. So make sure don't do any silly mistake. Right, so if you have anything, you can just ask me anytime. So thank you and all the best for your study.